elasticity, elastic bodies with examples. The property by virtue of which a body regains the original size or shape on the withdrawal of a deforming force on it is called elasticity. The property by virtue of which a body regains its original size or shape on the withdrawal of deforming force on it is called elasticity. Elastic bodies. The bodies which exhibit the property of regaining the original size or shape on the withdrawal of deforming force on them are called elastic bodies. Examples: metals, crystals, rubber, quartz, etc. In practice, there is no body which is perfectly elastic, but quartz is considered nearest to perfectly elastic. Therefore, the best elastic body is quartz fiber. We treat quartz fiber as the best elastic body. And then let us understand stress, strain, Hooke's law and modulus of elasticity. Under the action of a deforming force on a body, the restoring force per unit cross-sectional area is called stress. It is the restoring force per unit cross-sectional area of the body. So stress is it is generated under the action of a deforming force on a body. So when we apply a deforming force on a body, the restoring force per unit cross-sectional area that is set inside the body is called stress. So stress is restoring force divided by cross-sectional area, and that is F by A. So obviously SI unit is Newton per meter square or Pascal, CGS unit is Dyne per square centimeter, dimensional formula M1 L minus 1 T minus 2, force by area. Dimensional formula now M1 L minus 1 T minus 2. And what is strain? The change in dimension per unit dimension of a body is called strain. The change in dimension in reference to different dimensions we studied. Here generalized definition is change in dimension per unit original dimension of a body is called strain. And strain has no units and no dimensions, since it is the ratio of quantities of same nature or same dimensions. And now Hooke's law and modulus of elasticity. Within elastic limit, the stress in a body is directly proportional to the strain, and this statement is called Hooke's law. Within elastic limit, the stress that is set in the body under the deforming force is directly proportional to the strain it undergoes, and this is called Hooke's law. So within elastic limit, the ratio of stress to strain is called modulus of elasticity of the material of that specimen. The ratio of stress to strain is called modulus of elasticity, and it is defined as a property of the material of that specimen. SI unit again Newton per meter square or Pascal of modulus of elasticity. CGS Dyne per square centimeter, dimensional formula M1 L minus 1 T minus 2, same as that of stress. And now let us define longitudinal stress, longitudinal strain and Young's modulus of elasticity. We study this stress and strain, as I told you, in reference to the longitudinal factor, the bulk factor and rigidity factor, that is shearing factor, what we say. We discuss one after the other. Here longitudinal stress, longitudinal strain and Young's modulus of elasticity. If the deforming force is applied along the length of a body to cause a change in its length, then the restoring force per unit cross-sectional area is called longitudinal stress. So longitudinal stress is restoring force along the length divided by cross-sectional area. Again F by A, but this restoring force that is set is along the length. And by longitudinal stress, the length of body increases when you apply when the body is under longitudinal stress. The length of the body increases, but remember, volume and shape remains same. Body is subjected to a deforming force so that it undergoes longitudinal stress. In such context, length of the body increases. There is a strain along the length, but the volume and shape remains same. And longitudinal strain. If the deforming force is applied on the body to cause a change in its length, then the ratio of change in the length to the original length. Earlier we defined change in dimension to original dimension. Now the dimension is length. So we say the ratio of change in dimension to the original dimension is called longitudinal strain. So longitudinal strain is delta L by L, or simply E by L, change in length divided by original length. And then Young's modulus of elasticity. Earlier we have generalized the definition. Simply stress by strain is modulus of elasticity. Now for different dimension factors, we define different moduli of elasticity. Now it is in reference to the longitudinal stress and longitudinal strain. The ratio of longitudinal stress to longitudinal strain becomes Young's modulus of elasticity. So now to define it, we say as follows. If the deforming force is applied along the length of a body to cause a change in its length, then within elastic limit, all this is to be done within elastic limit, the ratio of longitudinal stress to longitudinal strain is called Young's modulus of elasticity of the material of the specimen. So Y is equal to F by A, longitudinal stress, divided by E by L, change in length by original length. So if we modify it, F by A into L by E, expression for Young's modulus. SI unit, Newton per meter square or Pascal. CGS unit, Dyne per square centimeter. Dimensional formula M1 L minus 1 T minus 2. And Y does not depend on dimensions of the specimen. Any modulus of elasticity is not defined for dimensions of the specimen. It is defined for material. So it depends only on the nature of the material. So Young's modulus, even though here in this expression L, A are present, it doesn't mean that Y depends on L and A. It is a property of material of the specimen. Now from this expression we can make conclusions like this. The stress to double the length of a wire, that is to produce 100% strain. Doubling the length means change in length equal to original length. It means the length of the wire is doubled, that is increased by 100%. So the stress that is set or that is produced to double the length of wire or to produce 100% longitudinal strain is equal to Young's modulus of the material of the wire. A numerical conclusion from this we can easily say, if E equal to L and F by A will be equal to Y. That's nothing but stress. Longitudinal stress is Y. If the length of the wire is doubled or the strain that is subjected to the wire is 100%.